For the next section of your test, you'll be finding the area of these quadrilaterals or shapes that we have been discussing. So with number 25, you have a square that has a perimeter of 24 inches. Since I'm finding the area, you'll notice that I always start by just writing the area formula, which in this case, area equals base times height. You'll notice that we had an area formula that said it equals the side length squared, but a square is a parallelogram, so I tend to use the same formula for the square, the rectangle, and the parallelogram because it's just base times the height. So since the perimeter is 24, we have to know that in a square all four sides are the same, and the perimeter is adding all of those together. So if you take that 24 and divide it evenly among the four sides, we very quickly find that each of these sides is 6. Now the height is always drawn from a vertex to the base at a right angle, but since a square has a right angle in all four corners, this side of 6 is the height and this side would be the base. So we're going to have an area of 6 times 6, which again would be 6 squared, as the other formula implies, for a total area of 36 inches squared. Now the triangle is half of a parallelogram, so our area formula here would be 1/2 the base times the height. So again, height goes from the vertex to the base at a 90 degrees. So 10 is the height, 12 is the base because that's what I'm drawing to. So I just have to fill in these numbers that I have. The base is 12, the height is 10, so 1/2 of 12 times 10 is 60 for a total area. And I'm not too worried about units squared here, but if it does, like in number 25, give us inches, we should say that it's inches squared or centimeters squared or whatever the units happen to be. 27, trapezoid. I'm looking for the area again, so I will start with the area equals 1/2 the sum of the bases, base 1 plus base 2, multiplied by the height. So the base 1 and base 2 is very simple. The first base is 10, plus the second base, which is 20, and then multiplying by the height. Now the problem with the height is 13 is not my height, and you may be tempted to just grab that number and plug it in. But if you were listening to the other two, the height has to go from a vertex to the opposite side at a 90-degree angle. And this side of 13 doesn't do that. So the height of my trapezoid has to be here. And I don't actually have what that is, so I'm going to have to figure out what that length is. Well, when in doubt, I cut the shape into shapes that I do know. For example, if I draw another height from this vertex, I just created a rectangle because the top and bottom are parallel, so the two heights will be parallel with 4 right angles here. So that's going to give me a rectangle, which means this length is 10. And since I have 10 left over of the full 20, that's going to go 5 here and 5 here. Now I'm not just guessing that. I know this because both sides are 13, and in an isosceles trapezoid, that's going to have to be the same leftover part. So for me, I'm going to have a right triangle, and I'm going to shade it in right over here. If I draw that right triangle with the height that I'm looking for, the 5 that I know, and the 13 that I was given in the beginning, I can do a Pythagorean theorem. 5 squared plus the height squared should equal 13 squared. I started to write 12 because that's the answer. It's a 5, 12, 13 if you know your Pythagorean triples. So 25 plus the height squared equals 169. So the height squared, when I subtract the 25, is 144, which is going to give me, when I square root, the height being 12. So if the height is 12, that's the number that's going to go into my formula. So 1/2 10 plus the 20 times the height, which we figured out was 12. So it's going to be 1/2 of 30 times 12, which ends up being 180. Now the next question here says, find the length of the diagonal. Well, the diagonal goes from one vertex, let me use a different color here, goes from the vertex to a non-adjacent vertex. So this would be the length of the diagonal here. I'm going to call it D for diagonal. Now the diagonal in an isosceles trapezoid is congruent, so it doesn't matter which one of these I draw, but this has nothing to do with the area. What I notice right away is a right triangle using that same height that I've already figured out is 12, and part of the base creates this right triangle with D, the diagonal I'm looking for, being the hypotenuse. So if you can't quite see that, let me draw it over here. The diagonal D is going from the vertex to the non-adjacent vertex. The height was 12 that we calculated and used for the area. And then I need to know what is this length. So we got to look very carefully. It's not 20 because it's only from this point to this point, which would be 10, and another 5, which would be 15. So my diagonal is going to be a Pythagorean theorem of 12 squared plus 15 squared equals that diagonal squared. So 144 plus 225 equals my diagonal squared. So 144 plus 225 is 369 equals my diagonal squared. And if I'm correct, there is no way to simplify that. So when I square root, I'm just going to get the diagonal is equal to the square root of 369. So what you're finding is we're going to use a lot of Pythagorean theorem even when you're finding the area, because sometimes that's what we use to get the height or another number that I need to finish out a Pythagorean theorem to find like a diagonal or something like that. So if you're unsure what to do, my suggestion is see if you have a right angle and look for the Pythagorean theorem. Rhombus and trapezoid again. Still finding area, so the area formula for a rhombus, I could use area equals base times height. But remember that would have to be from the vertex, straight down, 90 degrees. That's going to be a very hard distance to find. So the other formula that we had for the rhombus was the area is equal to 1/2 the first diagonal times the second diagonal. So if it gives me that D to F is 14, that's diagonal 1. And from G to E, that's diagonal 2. So this is a very quick problem if you remember this formula. So it's 1/2 diagonal 1 of 14 multiplied by diagonal 2 of 20, which ends up giving me a total of 140 for my area. This time on the trapezoid, very simple because I have the formula 1/2 first base plus the second base times the height. The first base is 6, the second base is 14, and you can see this time the height, straight down 90 degrees, is 8. So I'm just filling all those numbers in to the formula. So 6 plus 14 is 20, times the height of 8. We want half of that for our area, which would give me a total area of 80.